Hello, everyone. Welcome back. Today, I'm going to be talking about the rainbow rule, which is really I think the real term for it is the distributive property, but you can call it the distributive property or the rainbow rule. Either way works. So I think a lot of people will already be aware of this rule from grade 7 and 8, but we are going to review it again here because it is a rule that we're not only going to use in this course, but we're going to be using. You'll have to use this rule multiple times for multiple different types of problems, not just in this course, but in every high school math course that you're ever going to take. It will come up, and in some university level math courses, it will come up. So best to learn it now because it will come up again and be something that you'll use just on a regular basis automatically at some point. And maybe you're there already. Who knows? Maybe you think this is quite easy and what a simple lesson. And if so, fantastic. But if not, that's okay too. That is why the curriculum has decided the ministry has decided to actually include it in the curriculum again for the G streamed grade 9 as well, just to make sure that this skill is here, that we understand this skill, because it will help us out a lot later on. So what is the rainbow rule or the distributive property? Basically, it says that when we are multiplying something, by something else, by a polynomial in brackets, when we're multiplying a constant, or when we're multiplying a variable, or whether we're multiplying a variable and a constant by a polynomial, we need to multiply it by all parts of the polynomial, not just one. Because what a lot of people would do here that isn't right, I'll write it in red because this isn't right, they'd say, okay, 3 times x squared plus 2x plus 6. So they would write 3x squared plus 2x plus 6. Now, this is not the right answer. Why not? Because I only multiplied the 3 by the x squared. I forgot to also multiply it by the 2x and the 6, right? So the correct answer, the correct way to do this question would be to say it's equal to 3x squared plus 3 times 2x, which is 6x, plus 18, right? Because 6 times 3 is 18. Right? And so by doing it this way, I got all three of the numbers correct there. I got all three parts of this correct. In the first way, I got 3x squared is the same in both, but 2x plus 6, that isn't right. And let's talk about why this rule is the way it is. Well, think about our order of operations. In order of operations, we must add together, we must do what's in the brackets first, and then multiply that whole thing by 3, right? So if I'm only multiplying one part of it by 3, then I'm not really doing it justice in that sense. And so think of it that way, that if we were to know the values, right, if we were to know what x is, how would we solve this? We would add them all together, all three of these terms together. We'd add the x squared with the 2x with the 6 if we knew what x was, and then we'd multiply that whole answer by 3. We wouldn't just multiply part of it by 3 and then add on the other stuff after. Well, no, that's not how it works. That's not what the question is saying because of the brackets. So brackets are very key here, right? If these brackets weren't here the way they were, then we wouldn't have to use this rule, Or in other words, let's say that there was another number out here after the brackets. So I'm just going to say, let's say this question was actually asking plus another 10, for example. Well, this 10 would not need to be multiplied by the 3. The correct answer for this would just be 3x squared plus 6x plus 18x and then plus 10, right? Not plus 30 at the end. Nor would it be right to add these two things up, right? Because our very first order of operation here is figure out what's in the brackets, right? Add those up, multiply all those things by 3, and then add 10 very last if we go back to order of operations. And so this rainbow rule should never contradict our order of operations, right? So that's very important to keep in mind as well. Okay, so with all of that said, let's actually get into solving each and every one of these problems, as I do plan to solve all of these problems today, and then there are the answers over here as well. Okay, so let's start with the first one. Well, let's see. 3 times x squared is 3x squared. 3 times 2x is 6x. And 3 times 6 is 18. So there we go. All right, what about the second one? What's 5 times x squared? Well, that's going to be 5x squared. What's 5 times 4x? That's going to be 20x. And what's 5 times negative 3? That's going to be negative 15. And there's our answer. There we go. Okay, how about number 3? It says 2 times x squared. Well, that's going to be 2x squared. 2 times negative x, that's going to be negative 2x. And then 2 times 11, that's going to be plus 22. Good. Okay, and how about number 4? 4 times x squared is 4x squared. 4 times 2x is 8x. And 4 times 30 is 120. Which if you weren't sure that how 4 times 30 is 120, you have a couple options. You could use a calculator and find it that way. Or you could think, well, 4 times 3, well, that's 12, right? And so if we add an extra 0, right, there's a 0 added on to 30, then it would be, we'd add an extra 0 to the answer. So we get 120 is the other way of doing it. Okay, number 5, we have, this one's a little trickier. We have, instead of just a constant, we're multiplying a constant to everything. Now we're multiplying a constant and a coefficient, okay? So we're multiplying negative 3x to everything. So the first one is going to be negative 3x times x squared. Well, let's review from a few days ago when we talked about what do we do when we multiply together two exponents, right? With the same base, we add the exponents. And this x is really x to the power of 1, right? X just by itself is the same as x to the power of 1. So all we have to do here is add these exponents. This would be negative 3x cubed, right? Because 1 plus 2 is 3. Okay, so if that is unfamiliar, make sure you go review that lesson where we talk in detail about all the exponent laws. I believe the lesson is called Exponent Laws, and I believe it was from the previous unit. Okay, next one, we have negative 3x times negative 7x. Well, first let's figure out what's negative 3 times negative 7. That would be plus 21. So I'll write plus 21. And then we have x to the power of 1 times x to the power of 1, right? Or x times x. Well, what's x times x? That's the same as x squared. And then we have plus 1 at the end. So negative 3x times 1, well, that's just going to be negative 3x, right? Anytime we multiply anything by 1, we just get the same thing back. Good. Okay, let's try number 6. So number 6 is very similar. Here we have negative 6x times 3x squared first. So that's going to be negative 18x cubed. Then we have negative 6x times positive 5x, which that's going to be negative 30x squared. And then we have negative 6x times negative 10. That's going to be two negatives make a positive. So that's going to be positive 60x. And there we go. Okay, let's move on to number 7. Okay, so we have 5x times negative 2x squared. That's going to be negative 10x cubed, right? Then we have 5x times 8x. That's going to be plus 40, and then x times x is x squared. So plus 40x squared. And then we have 5x times 12, which that's going to be 60x, right? Because 5 times 12 is 60. And then we just include the x there as well. We're still multiplying by x. Good. Okay, let's try number 8. 8x times 2x squared, well, that's going to be 16x cubed. And then we have 8x times 6x, which is 48x squared. Then we have 8x plus 10, which is 80x. And there we go. All right, let's try number 9. We have 3x squared times 2x squared. Well, just back from our lesson about the exponent laws and multiplying together monomials. What would this be? What would it be? 3x squared times 2x squared. Well, first we multiply together the coefficients, so we get 6. 3 times 2 is 6. And then we multiply x squared times x squared, which, as we know, we just add up the powers, right? We add 2 plus 2 and we get 4. So it's x to the power of 4. Okay, next one we have 3x squared plus 20x, or times positive 20x. Well, 3 times 20 is 60, right? And then x squared times x would be x cubed, so it's 60x cubed. And then we have 3x squared plus 12 times 12, which is 36x squared. Awesome. Okay, let's do number 10. We have 6x squared times negative 2x squared. Well, that's going to be negative 12x to the power of 4. Then we have 6x squared times 5x, which is going to be 30x cubed. Then we have 6x squared times 30x, times negative 30, which is going to be negative 180x squared. Good. Okay, so now we're getting into some higher powers here. So we have 9x cubed times x squared. Well, let's think about that. We're going to keep 9 as our coefficient here. And then x cubed times x squared. Well, again, we add the exponents. So we add 3 and 2, and we get 5. So the new power is x to the power of 5. Then let's move to the next one, 9x cubed times x, right? Well, again, x is just the same as x to the power of 1. So that would be 9x to the power of 4 overall. We're going to do 3 plus 1 is 4. And then we have 9x cubed times 1, which, again, anything times 1 is just the first thing we started with. So it would just be 9x cubed. Very good. Okay, let's move on to number 12. Okay, so we have, for number 12, negative 5x to the power of 6 times 3x squared. So what do we do first? We always multiply the coefficients first. So what's negative 5 times 3? Well, that's negative 15. What's x to the power of 6 times x squared? Well, how do we deal with that? We add up the powers. So that's going to be x to the power of 8 because 6 plus 2 is 8. Okay, then we have negative 5x to the power of 6 times negative 12x. Well, what's negative 5 times negative 12? That would be plus 60, right? And then what's x to the power of 6 times x? That would be x to the power of 7. Awesome. Okay. All right, and then what's our last one? We have negative 5x to the power of 6 times 30. So that would be, well, what's negative 5 times 30? That would be negative 150. And then x to the power of 6, it just stays just the same. Very good. All right, and how about 13? 13. We have negative 2x cubed times 3x squared. Well, that would be what? That would be negative 6 x to the power of 5. Then we have negative 2x cubed times 4x, which would be negative 8x to the power of 4. And then we have negative 2x cubed times 5, which is negative 10x cubed. There we go. Okay, I want to talk about 14 because it's a little bit different in the sense that now we have two variables, but we treat it no different. If there's any variables that, that coefficient or these variables that we're multiplying, can go with, we apply those same principles. Otherwise, we can just leave the variable as is. So, for example, the first part of the question asks, what is x squared y squared times x squared? Well, let's lump those terms together, the x squared and the x squared. Well, what's x squared times x squared? That would be x to the power of 4. And because there's no y or y squared or anything else, it's, inside these brackets, we just copy it down from before. It's just y squared. Then we have x squared y squared times 2x. So what's that? Well, that's going to be a 2 there. And then we have an x squared times an x, which we know is x cubed. And then we have y squared just on its own. And last but not least, we have x squared times y squared times 1, which is just going to be x squared times y squared, right? Because again, multiplying anything by 1 just gives us back what we started with. It doesn't actually do anything. And so we're good. All right, and same deal with number 15. We have 4x squared y squared times negative x squared. That's going to be negative 4x to the power of 4y, right? Because we multiplied the negative sign in the 4, we got negative 4. Right? Because a negative sign is the same as negative 1, keep in mind, right? And so negative 1 times 4 is negative 4. Then we have x squared times x squared, which is x to the power of 4, just like the last example. And then the y, there's nothing, the y can combine with. So the y just stays put. Okay, now we have negative x. 4x squared y times negative x. Well, that is going to be negative 4x cubed y, right? This time we just have x that we're multiplying to x squared. And so we're going to get x cubed and not x to the 4 because, again, x is the same as x to the power of 1. And last but not least, we have times 10. So what's 4 times 10? Well, that's 40. And then the x squared y just stays as is because we don't have any variables to combine neither the x nor the y with. Good. Okay, let's do number 16. It says 5x squared y times x squared. Well, that's going to be 5x to the power of 4y. Then we have 5x squared y times 2xy. That's going to be plus 10x cubed y squared. Now, why is that? Let's talk about it. Well, 5 times 2, right, is going to be 10. And then x squared times x, well, that's just the same as x to the power of 2 times x to the power of 1. So we added those exponents to get 2 plus 1 is 3. And then we did y times y squared. We did y times y. And y times y is just y squared, right? By exponent laws, or even just thinking about it of, if we multiply the same thing twice, then it's that base squared. Good. Then we have 5x squared y times 7, which is going to be just 35x squared y. No variables to combine with, so variables stay the same. We just multiply the 5 and the 7, essentially. Good. Okay, let's try number 17. So what's the first part for number 17? It asks 3xy times 2x squared. Well, let's see. 3 times 2 is 6, so let's put that first. X times x squared is x cubed, right? If we add up those exponents. And then we just have a y there, so we'll just leave it as is. Next, we have plus 2xy. So again, 3 times 2 is 6. X times x is x squared. And y times y is y squared. So we have 6x squared y squared. Then we have, we're going to multiply 3xy to y squared. So we're just going to copy down the 3 and the x as before. And then we're going to multiply together, right? When we multiply the whole terms together, we're going to get y times y squared, which is going to be y cubed. So there's our answer. Okay, let's try number 18. What is 4xy squared times 3x squared? So that's going to be 3 times 4 is 12. What is x times x squared? That's going to be x cubed. And then we have y squared. Good. All right. Next, we have 4xy squared minus 5xy. Well, that's going to be negative 20 x squared y cubed. Like that. And then we're going to have 4xy squared times 6y squared. So that's going to be 24 x y to the 4, right? Because we multiply 4 and 6 to get 24. The x stays as is. Then the y squared times y squared is y to the power of 4. Okay. All right. Okay, let's move on. Okay, so number 19. 3x squared y squared z times 4 different things. Okay, so let's start with the first part of this question. The first part of this question asks 3x squared y squared z times 7x squared. Well, what's 3 times 7, first of all? That's going to be 21. And then we have x squared times x squared, which is x to the power of 4. And then the y squared and the z just stay as is. Okay, the next part we have 3x squared y squared z times 2y. So 3 times 2 is 6, and then the x squared just stays as is. The y squared gets multiplied to y, so what's y squared times y? That's going to be y cubed, and then z just stays as is. Then the next one is 3x squared y squared z times z, so that's just going to be 3x squared y squared stays as is. Z times z is z squared. And then we have plus 4w. So this is going to be plus, let's see, well, 3 times 4 is 12. The x squared, y squared, and z stay as is, but we also multiply by a w. So we add a w into the mix. Well, when I say add, I really mean we multiply it because we're multiplying it, but we add it to the term, so to speak. It's included in the term as well. But we're multiplying it, not adding, to be clear. Good. Okay, and let's do number 20 last but not least. We have negative 2xyz times 3x squared. That's going to be negative 6 x cubed yz, right? Because I multiplied the negative 2 with 3. And then x squared, x times x squared would be x cubed, and the y and the z stayed as is. Then we have times 2y squared. So that's going to be negative 4xy cubed z. And then next we're going to have negative 2xyz cubed. And then last but not least, we're going to have plus 8xyz w squared. Very good. All right, so last but not very least, we have to find the area of the following shapes. So remember, area is base times height. So all this is really asking us to do is take this number and multiply it by this number. And then same with here, multiply these two together, and that'll give us the area. So let's do that. What's 4x squared times 2x squared? That is going to be 8x to the power of 4, right? 8x to the power of 4. Then we have 4x squared times negative 5x. That's going to be negative 20 x cubed. And then 4x squared times 8 is going to be plus 32 x squared. All right. Awesome. Okay. Now for B. We have 5x squared times 3xy squared. That's going to be 15 x cubed y squared. Good. And then we have 2x times 3xy squared, which is going to be 6x squared y squared. And then we have minus 7 times 3xy squared, which is minus 21xy squared. And there we go. All right, well, that is it for today. That is it for the rainbow rule, aka the distributive property. Good work today, everyone, and we will see you back next day. Bye, everyone.